Hey there, everyone! In today's video, we're diving into the awesome world of Python lists. We'll explore some more handy list methods together and wrap up by talking all about lists. And don't worry, we won't stop there. We'll also chat about tuples in a bit. So in this presentation, we're going to dive into working with lists in Python. We'll start things off by showing you how to modify items in a list, and then we'll introduce you to the super handy appended method for adding items to your list. Next up, we'll cover how to completely clear out your list using the clear method. After that, we'll chat about looping through lists with for loops and introduce you to list comprehension. It's cool, we promise. Finally, we'll cover a few more list methods like sort, reverse, copy, and join lists. So sit back, relax, and let's get to it. First, we will learn how to change list items. Changing items in a list is a common operation in Python. You can change an item in a list by accessing it with its index and assigning a new value to it. For example, imagine you're managing a to-do list for your day's tasks. Each task is represented by an item in your list. Throughout the day, tasks might change, get completed, or new ones might come up. Let's see how changing list items can reflect this situation. Okay, first things first. Imagine you have a list of tasks for the day, just like a to-do list. We're going to use Python to manage this list. Open up your code editor, and let's get started. Let's create a to-do list for the day and put some tasks in this list like buy groceries, finish homework, go for a run, and read a book. All right, let's say you've finished your homework and now you want to call a friend instead. To do that, you need to change the task in the list. So, let's see how we can change finish homework to call a friend using Python. We're working with our to-do list that we set up earlier. Now remember, we're using something called an index to access a specific item in the list. Just like a book's index helps you find a particular page, the index in a list helps us locate an item. In Python, indices start at 0. So, the first item is at index 0, the second item is at index 1, and so on. In our case, finish homework is the second item in the list, so it's at index 1. This line is where the magic happens. We're telling Python to go to index 1 of our to-do list and replace the existing task, which is finish homework, with the new task, call a friend. After we make this change, if we are ready to print the to-do list using print function, you'd see that the updated task, call a friend, has replaced finish homework. All right, it's time to run the code. And see the outcome? And that's all there is to it. You've successfully changed an item in your list using Python. This might seem simple, but it's a fundamental concept that you'll use a lot when working with lists. It's like editing your tasks for the day without rewriting the whole list. In the next steps, we'll explore adding new tasks and removing tasks from our list. So, stay tuned and keep coding. Now we will learn about changing a range of item values in lists. All right. Now let's take our list manipulation skills up a notch. Imagine you have a bunch of tasks that you want to update all at once. Maybe you want to change the priority of tasks 2 to 4, or mark them as completed. Python makes this super convenient. Let's dive into changing a range of list item values. Earlier, we saw how to change a single item in a list. Now, imagine you have a range of items that you want to update. Let's say tasks 2 to 4 need a priority boost. We're going to use a powerful technique to achieve this. In Python, we can use a concept called slicing to work with a range of items in a list. It's like taking a slice of pizza from a whole pie. You're selecting a portion. Let's look at how this works. We'll be working with a portion of our to-do list, tasks 2 through 4, and we'll give them a high priority status. Let's see how it's done. Here, to-do list, 1 to 4, represents the range of items we want to change. But remember, Python starts counting from 0. So to-do list U1 is actually the second item, and to-do list 4 is the fifth item. But we want to update tasks 2 to 4, so we use 1 to 4 and we're replacing this range with our new values. High priority, and high priority. This effectively updates tasks 2 to 4 with high priority statuses. Now we want to print the updated list using print function. As you can see, when we run this code, the slicing operation captures tasks 2 through 4. Then our assignment replaces them with high priority across the board. Congratulations! You've just learned how to use Python's slicing technique to modify a range of tasks in your list. This is an elegant way to make batch updates efficiently. And oh, your friend reminded you to water the plants. No problem. We can add that task to our list using the append method. Now, let's move on to the exciting part. Adding a brand new task to our to-do list. Just imagine you remembered something important you need to do today, like watering the plants. We'll use Python to add this task to our list. So let's dive into it, We're using a method called append to add an item to the end of our to-do list. The append method is a useful tool for adding items to an existing list. It works by taking the argument passed to it and appending it to the end of the list. This can be particularly helpful when building lists dynamically or when working with user-generated data. To use the append method, simply call it on the list you want to modify and pass in the item you want to add. This line is like telling Python, "Hey, add the task, water the plants to the end of the list." Now we print our list using print function. When you run this code, you'll see that water the plants has been added to the list. See, the append method does the job effortlessly. It's like placing the new task right at the end of your list of tasks for the day. Now let's explore a nifty trick that Python offers, adding items from one list to another. Think of it as merging two to-do lists into one. We'll use this technique to show you how easy it is to combine lists and make your coding life simpler. Appending items from one list to another can save you a lot of time and effort. Imagine you have a second list of tasks that you want to tack on to the end of your main to-do list. Let's dive into how to do this. In Python, you can use the extend method or the plus operator to append items from one list to another. It's like pouring the contents of one container into another. All right, let's create a main to-do list. And we put some tasks inside the list. Let's say, buy groceries, finish homework, go for a run, and read a book. We have created our main to-do list. Now we will create another list with extra tasks and insert tasks like call a friend, learn Python, clean the house. Our goal is to combine these lists by appending the items from the extra tasks list to the main to-do list. All right. Let's take a closer look at the extend method in Python and how it works to combine lists. This method is like a magical bridge that connects one list to another, letting us merge them effortlessly. I'll guide you through each step so you'll become a pro at list manipulation. This line of code is where the magic happens. Python's extend method reaches into the extra tasks list and takes each task one by one, adding them to the end of the main to-do list. Now it's time to print our updated list, and when we run this code, the main to-do list now includes all the tasks from both lists, effectively merging them together. One more thing to remember: if you access the extra tasks list, it remains unchanged. Let's print this extra tasks list and see whether it remains unchanged or not. We will run this code and see the result. There you have it. It remains unchanged. And that's it. You've successfully used the extend method to combine lists. This technique can be a game changer when you're dealing with multiple sources of data that you want to merge seamlessly. All right, Let's talk about removing items from a list in Python. Sometimes, you might change your mind about a task or find out it's not needed anymore. In our to-do list, for instance, you might decide not to read a book after your run. We're going to show you how to do just that using Python. When you want to get rid of an item from a list, Python provides a simple way to do it. Think of it as crossing out a task that you no longer need. Let's see how this works in code. We have mainly 3 ways to remove items from a list: using del keyword, remove method, and pop method are commonly used for managing and manipulating lists in programming languages like Python. Let's use the example of a to-do list to explain these concepts. So, the del keyword in Python is used to delete an item from a list or any other data structure. You provide the index of the item you want to delete. For instance, if you want to remove read a book from your to-do list, you can write the del keyword and the list name, then index of the item you want to remove. Let's print the updated list after removing one task using del keyword. We run this code and see the result. There you go. We have successfully removed a task from our list. Remember, the del can also delete the list completely. For example, we want to delete our to-do list completely. We can do like this. Just mention del keyword and name of the list. Now we will run this code and see the result. There you have it. We deleted list. Now we will learn about another method. That is, remove method. The remove method in Python is used to remove the first occurrence of a specific value from a list. In the case of your to-do list, let's say you want to remove buy groceries. Let's write the code using remove method. Just write down the list name and give a dot next to list, and you will see a list of methods. Just select remove method from the list of options. Now we have list and remove method. It's time to select the task to remove buy groceries. All right, now we use print function to see the updated list. Let's run this and see the result. There you go. We have successfully removed a task from our list. Okay, so if you want to remove a task using specific index from a list, here another method comes to rescue. That is pop method. The pop method is used to remove and return an item from a specific index in a list. It's different from del because it not only removes the item but also returns it. For example, if you want to remove the task finish homework and get it as a result, let's see how we can do that. I am creating a new list called finish task, and I want to remove a task from the to-do list using pop method and index, and it assigns it to finish task. All right, now we use print function to see the updated list. Let's run this code and see the result. There you go. Whether you want to delete tasks at specific positions, remove tasks by value, or even retrieve and remove tasks simultaneously, these methods provide various ways to work with your list of tasks. Now, we will jump into another list method. Now, we'll learn about the clear method for lists. It's used to empty a list, removing all its elements. The syntax is simple. List name. Dot. Clear. Let's dive into some examples. Imagine we have a list called fruits with some fruit names: apple, banana, orange, grape. We'll use the clear method to empty the list. The clear method is used to empty a list, removing all its elements. This can be useful when you want to start fresh with an empty list. We apply the clear method to the fruits list. After this step, the list will have no elements left. Let's print the fruits list after using clear. The output will show an empty list because we cleared all elements. Let's run this code and see the result. There you go. We have an empty list. Now, we'll dive into a code example to understand how to clear a list and reuse it with new data. We start by creating a list named numbers, containing the numbers 1, 2, 3, 4, and 5. This is our initial set of data. The clear method helps us to remove all elements from a list. It's like giving the list a fresh start. So our list numbers holds 1, 2, 3, 4, 5. The goal is to clear this list and reuse it. The clear method is called on the numbers list. This method removes all the elements from the list, effectively making it empty. After this step, our list will be as good as new, empty and waiting for new data. Now that we have a clean slate, we want to reuse this same list. Our plan is to fill it up with new numbers, specifically from 6 to 10. We'll employ a for loop to add these new numbers to our list. The for I in range 6, 11 line sets up a loop that goes from 6 up to, but not including, 11. During each iteration of the loop, the variable I takes on the values 6, 7, 8, 9, and 10. Using a loop is like telling the computer, "Hey, do this thing over and over for me." We'll use a loop that starts from 6 and goes up to 10. The numbers dot append. I-line adds the current value of I to the numbers list using the append method. This effectively adds each of the numbers 6 through 10 to the list. Finally, we print out the modified numbers list, which now contains the numbers 6, 7, 8, 9, and 10. That's a wrap. You've mastered clearing a list and reusing it. The clear method and loops are powerful tools in your Python journey. If you found this video helpful, don't forget to give us a thumbs up and subscribe. Feel free to ask any questions you have in the comments below. Now we will dive into another interesting concept. Now we are going to learn how to loop through the list like a pro. Don't worry if you're new to coding. I'll guide you through every step. Let's get started. All right. Before we begin, let's understand why loop through lists and what is the benefit. All right. Imagine you have a list of items and you want to perform the same action on each item, like printing them, performing calculations, or checking for specific conditions. Instead of writing repetitive code for each item, you can use loops to automate the process. First, we will learn looping with for. All right. Let's write some code. Before we start looping, let's understand the star of our show, the Python list. Imagine a list as a collection of items, just like your favorite snacks neatly lined up in a row. We're going to loop through this list of fruits. We've got a list called fruits containing 4 items: apple, banana, orange, and grape. Now, pay attention to the for loop. It's our tour guide through the list. Now let's dissect that for loop. Here's how it works. We're telling Python to go through each item in the fruits list one by one, and for each item, we're going to do something with it, which we'll see in the next line. Time to reveal what we do with each fruit. Here's the magic moment. We're using the printed function to show each fruit's name on the screen. The variable fruit holds the current fruit we're looking at in the loop. It changes with each loop iteration. Let's run this code and see the outcome. There you have it, loop conquerors. Here, the loop starts with apple. It prints apple. Then it moves on to banana, and guess what? It prints banana. This continues until it goes through all the fruits. The loop knows when to stop because it's reached the end of the list. You've just explored the world of looping through lists. Remember, the for loop is like your guide, taking you on a journey through each item in the list. This is just the beginning. Practice, experiment, and soon you'll be looping like a pro. If you found this tutorial helpful, don't forget to give it a thumbs up and subscribe. All right? Now we will loop using range for index. We're diving into the depths of lists and indices. If that sounds a bit technical, fear not. I'll break it down into bite-sized pieces so you'll have a crystal clear understanding by the end. Let's jump right in. Before we dive into the code, let's talk about lists. Think of a list as a virtual basket where you can store items. In our case, we have a list of fruits. All right, let's introduce you to a new kind of loop. We've got a list called fruits, just like before. But this time, we're going to take a journey through this list using the for loop. And guess what? We're going to learn about indices, which are like the positions of items in the list. Here's what's happening. We're using a for loop, just like before. But instead of looping through the actual items, we're looping through a range of numbers that correspond to the indices of our list. The len of fruits gives us the number of items in the list, and range creates a sequence of numbers. Now, let's see what we do inside the loop. This is where the magic happens. With each loop iteration, the variable index takes on the value of the current number in the sequence we generated earlier. So, we're using this index to access the elements in the fruits list. We use print statement, indicating that we want to display something on the screen. The letter F, right after the opening parenthesis, indicates that we're using an F string. An F string is a special kind of string that allows us to embed expressions inside curly braces. These expressions are evaluated and their values are inserted into the string. This part of the F string is the first part of the text we're printing. It includes the word index, followed by the value of the index variable, which holds the current index of the loop, and a colon. The curly braces act as placeholders for the value of index. Inside the same F string, we have another placeholder. This one is for the fruit element in the fruits list at the current index. The expression fruits index retrieves the fruit's name from the list using the current value of index. Let's bring it all together and witness the magic in action. For each index, we're printing out the index itself and the corresponding fruit in the list. This way, we're getting a sneak peek into the positions of each fruit. Let's run this code and see the result. There you have it. Kudos, amazing learners. You've ventured into the world of indices and lists. You've seen how these numbers, the indices, guide us to specific items in the list. Remember, indices start at 0 and go up to the number of items -1. Keep practicing, and soon you'll be navigating lists like a coding champion. Now we will jump into another loop concept. Now we will learn about while loop. All right, let's start by imagining that we have a box full of marbles, and each marble is like an item in a list. In Python, we use lists to store collections of things, just like our box of marbles. We will create a list called marbles with different colors: red, blue, green, yellow. Each color represents a marble, just like how each item in a list has its own value. And to keep track of which marble we're looking at, we have our index set to 0. Now, we're going to start our loop using while, and this loop will run as long as our index is less than the total number of marbles in the list. We're using the len function to find out how many marbles are in the list. Inside the loop, we'll grab the marble at the current index using marbles index. We'll then store it in a variable called current marble. And to make it visible, we'll print out the color of the current marble. After we've looked at the current marble, we want to move on to the next one. So we simply add 1 to our index. This helps us progress through the list. And that's the beauty of loops. The loop continues until we've gone through all the marbles in our list. Now we will print the result using print function. The current marble is... Let's run this code and see the result. And there you have it, explorers. We've uncovered how to use a while loop to go through each item in a list, just like going through our colorful marbles one by one. Keep practicing, and soon you'll be looping through lists like a coding maestro. All right. Now we're diving into a really cool topic, list comprehensions. Don't worry if that sounds a bit fancy right now. By the end of this video, you'll be a pro at using them, Okay, let's start with something we all know. Lists. You can think of a list like a collection of items, just like your shopping list. Our goal is to take each item in a list, do something with it, and create a new list out of the modified items. We can do this using a for loop, but there's a nifty shortcut called a list comprehension that makes it super easy. All right. Let's get our hands dirty with some code. Imagine we have a list called original list, and it contains 1, 2, 3, 4, and 5. We want to double each of these numbers and create a new list with the doubled values. So, We also make an empty list called doubled list to store our modified numbers. Now, here's where the action happens. We use a for loop to go through each num in the original list. Inside the loop, we take the current number, double it by multiplying it by 2, and then add it to our doubled list. But wait, this is using for loop. Now, brace yourselves, because here comes the exciting part. List comprehensions. Look at this. We start with our original list, just like before. Now, the magic is in this part. So, remember, our goal is to create a new list called doubled list, where we'll store the numbers from original list. But each of them will be doubled. The whole thing starts with the square brackets. Think of these brackets as a container for the new list we're going to create. Right after the opening bracket, we have number 2. This part here is what we want to do to each number in the original list. Now, the interesting part, for num in original list, this is like saying, hey, let's go through each number in the original list and do the thing we talked about earlier to it. Imagine we're going to take a magical journey through the original list, and at each step of the journey, we're going to double the num. Picture yourself standing at the beginning of the original list. You're about to go on a journey through all the numbers in it. As you begin walking through the list, at each step, you grab a number, that's the num we're talking about, and you multiply it by 2. This doubling is what num2 means. After you've doubled the number, you put the result into the doubled list that we set up earlier. It's like putting each doubled number into your shopping cart, or in our case, the new doubled list. You keep doing this for every number in the original list, one by one, until you've gone through the entire list. Finally, when you've finished the journey and have doubled every number, you've also filled up your doubled list with all the modified numbers. Let's run this code and see the result. And that's it. You've successfully created a new list, doubled list, using this special technique called a list comprehension. So, to sum it up, this line of code is like a magical spell that takes each number in the original list, doubles it, and adds it to a new list called a doubled list. And that's it, folks. Now we will dive into another list method. We're going to dive into a fundamental topic that'll help you organize your data like a pro. We're talking about sorting lists using the sort method. All right, let's start by creating a list of numbers we want to sort. I'll call it numbers for simplicity. Now, to sort this list in ascending order, we're going to use the sort method. It's super simple. Just type numbers and dot. The dot operator in Python is used to access the methods and attributes associated with an object. In this case, numbers is the object, which is a list, and we're using the dot operator to access its methods. It pops all the available list methods, and we select sort method from the list. To see the magic happen, let's print out the sorted list. When we run this code, Python sorts the list in an ascending order by default. Now, what if we want the largest number to come first? No worries. We can sort in descending order too. Just add a little parameter. We pass an argument to the sort method, reverse equal to true. This is an argument that we are passing to the sort method. When you set reverse to true, it instructs Python to sort the elements in descending order instead of the default ascending order. Now let's run this code and see the outcome from this code. There you have it. We have a list in descending order. Remember, the sort method works with various types of elements, not just numbers. It can sort strings, objects, and other types of data, too. Now, we've got another interesting topic lined up for you. The copy method for lists in Python. So let's dive right in. Okay, so first things first. What exactly is the copy method? Well, in Python, a list is an ordered collection of items. And sometimes we need to make a copy of a list, maybe to modify it separately or to keep an original version intact. That's where the copy method comes in handy. It creates a new copy of the list, which is independent of the original list. Now let's take a look at the syntax of the copy method. It's pretty simple. New list equal to old list dot copy. Here, new list is the name of the new list that we'll create, and old list is the list we want to copy. I know this might sound a bit abstract, so let's jump into some examples to make things crystal clear. Let's say we have a list of favorite fruits. Next, we're going to create a copy of the fruits list using the copy method. We're using the copy method on the fruits list and storing the copied list in a new variable called fruitsCopy. This new list will initially have the same elements as the fruits list. Now let's add a new fruit, grape, to the copied list. With the append method, we're adding grape to the end of the fruits copy list. This will only affect the copied list, leaving the original fruits list unchanged. Finally, we'll print out both the original and copied lists to see the result. In these lines, we're using the print function to display the content of the fruits list and the fruits copy list. This allows us to compare the two lists and observe how the copy method maintains the integrity of the original list. Let's run this code and see the result on B. And there you have it. We've successfully explained and walked through each line of the code step by step. By using the copy method, we've created a separate copy of the fruits list and added a new fruit to the copy without affecting the original list. This technique can be really useful when you want to work with lists in Python without altering your original data. And another way to copy a list is using slicing method. We have total 12 different ways to copy a list. We will post a separate video on these 12 ways of copying lists. And you cannot copy a list simply by specifying list 1 equal to list 2, because list 2 will only be a reference to list 1. And changes made in list 1 will automatically also made in list 2. And if you have any questions or suggestions, please ask in the comment section, and if you found this tutorial helpful, don't forget to give it a thumbs up and subscribe. And now, we will dive into one final list method and we'll wrap up. We've got something really cool to discuss: Python list joining. Don't worry if that sounds a bit intimidating right now, because by the end of this video, you'll have a solid grasp of this concept. I promise. All right, let's jump right in. Imagine you have two lists in Python, and you want to combine them into a single list. That's where list joining comes into play. It's like merging the contents of two lists together to create a new, bigger list. Let's get hands-on with some code. Fire up your favorite Python environment, and let's follow along together. Let's create two lists. We will create a list called fruits, and we put some fruits: apple, banana, orange. Now we have one list. Let's create another list called colors, and insert some colors: red, yellow, orange. All right. We have two lists. We want to combine them into one big list called combined list. We achieve this by simply using the plus operator between the two lists. As you can see, the combined list now contains elements from both fruits and colors. The order of elements is maintained, and we have a new list containing all the items. Let's print our combined list using print function. Let's run this code and see the results. There you go. We have joined two lists using plus operator. But wait, there's more. Python also provides another way to join lists using the extend method. Let's take a look at that. We can use extend method to join lists. The line fruits.extend. Colors is where the magic happens. We are using the extend method on the fruits list. In Python, methods are actions that can be performed on objects, like lists. The syntax for using a method is object.method. In this case, object is the list fruits, and extend is the method we're calling. The extend method does exactly what it sounds like. It extends or adds to the current list. It takes another list, in this case colors, and adds its elements to the end of the list on which the method is called, fruits. Unlike some methods that create a new modified version of the object, the extend method modifies the list directly. After this line of code, the fruits list will be updated to include the elements from the colors list. Imagine it like two boxes, fruits and colors. We're taking the items from the colors box and putting them into the fruits box. The items maintain their order, so the orange from colors comes after the orange from fruits. Print. Extended list, fruits, is used to display the updated fruits list. It uses the print function to show the list with the added elements. When we run this code, the output will be something like extended list, apple, banana, orange, red, yellow, orange. The fruits list has been extended with the elements from the colors list. And that's a wrap, folks. We've delved into a variety of powerful list methods that will undoubtedly level up your programming game. From modifying items and utilizing the efficient append method to clearing lists with ease using clear, we've covered it all. And don't forget, we've created a separate video that demonstrates a real-time mini project using Python lists. Make sure to watch it to gain insights into how Python lists function in practical scenarios. But that's not all. Our journey doesn't end here. In our upcoming video, we're going to delve into another essential topic: tuples. These ordered, immutable data structures have their own unique set of features and use cases that will expand your Python repertoire even further. So, if you're excited to broaden your understanding of Python's data types, smash that subscribe button and ring the notification bell so you won't miss our next episode. Until then, happy coding, and I'll catch you in the next video.